Alright, last video for today. I have one more quadratic example just to help you feel more comfortable with the nuances of the quadratic problems and to see how you could solve a quadratic problem even if it's a reciprocal function. So let's take a look at this example problem. Let's consider 3 times the cosecant squared of x minus 2 cosecant of x is equal to 2. And as usual, here we'll have the restriction that our x value needs to be in between 0 and 2 pi. And since we're working with approximations, remember 6.28 is right around the value of 2 pi. So here, if I'm trying to solve a quadratic, I always want to get it into standard quadratic form. So I want to subtract over this 2. So that will give me 3 times the cosecant squared of x minus 2 cosecant of x minus 2 is equal to 0. So now, if I look at this setup, I'm not going to be able to factor this expression. So it's going to be another one where I need to use the quadratic formula to get to my final answer. And remember that the quadratic formula is equal to your negative b term plus or minus the square root of b squared minus 4ac all divided by 2a. So what I want to do is look at my terms here. My b value is negative 2. So I'm not solving for x, but I'm solving for cosecant of x. And I'm going to take that negative 2. That's my negative b. So negative 2 is just 2. Plus or minus, I've got the square root of negative 2 squared minus 4 times my a term, which is 3, times my c term, which is negative 2. And all of that is divided by 2a, which is 2 times 3. So this is my setup to use the quadratic formula. And so what I want to do is to go through and simplify this expression. So if I simplify what's under the radical, I get negative 2 squared minus 4 times negative 3 times negative 2. And that's going to give me the square root of 28. So if I simplify this expression, I get 2 plus or minus root 28, all divided by 2 times 3, which is 6. So that means I'm going to have two answers, one where I do 2 plus root 28 over 6, and one where I do 2 minus root 28 over 6. So if I plug that into my calculator, 2 plus root 28, that's going to give me 7.29. Divide that by 6, and one of my answers is going to be 1.215. Then I just take the negative version. So if I have negative minus root 28, divide that by 6. So when I do the negative version of the quadratic formula, that will give me negative 0.549. Okay, so those are the two results I get from my quadratic formula. What I need to remember here, though, is that those aren't x values, those are my cosecant of x values. So here I have cosecant of x is equal to 1.215, and I have cosecant of x is equal to negative 0.549. Now, unlike with my previous example where I was working with sine right away, I could go ahead and take my inverse trig function just by using my inverse sine button on my calculator. Now I'm working with cosecant, so I have to change this so that I'm working with either sine, cosine, or tangent, so that way I can use my calculator to solve. So remember, cosecant is just 1 over sine. Right? We know cosecant is equal to 1 over sine. So what I can do to go from cosecant to sine is just to take 1 and divide it by the number that's on the right-hand side. So if I do 1 divided by 1.215, I get 0.823. Same thing over here. If I want to go from cosecant to sine, I'm just going to divide. So I'll have 1 divided by negative 0.549. Sorry, I think my phone's ringing in the background. That will give me, and this is sine of x, negative 1.821. So So here I have two different sine expressions, but what I want to consider is that sine needs to be in between -1 and +1. This is less than -1, so I'm not going to get an answer from this expression. So what I need to do here is to take my inverse sine, that should say inverse sine of 0.823 is equal to x. So we're going to go to our calculator. Inverse sine of 0.823, and we want to see what expression that gives us. So that's going to give us 0.967. So that's one of my answers. I'm sorry about the telephone. Now remember, I'm trying to report my answers that are in between 0 and 2 pi. So in between 0 and 6.28. This number is in between 0 and 6.28, so that is one of my solutions. But what I need to consider is that if I'm solving between 0 and 2 pi, I'm going to have two places where my sine value gives me the same expression, in this case 0.823. So let's consider our circular reference frame. So remember, we have 0, we have pi over 2, we have pi, and then down here we have 3 pi over 2. So this is a setup of my circular reference frame. So at one point in my circular reference frame, I have 0.967. And if I draw out that expression, 0.967 is right around here. So notice that this is where all of my trigonometric functions are positive. So I'm going to need another result that also gives me a positive sine value, because I'm looking for positive 0.823 as the resultant sine value. So if I consider in which quadrants my trig functions are positive, all of them are positive here. Sine is positive in quadrant 2, and then tangent and cosine are what are positive in the other quadrants. So I'm going to need a reference angle in this quadrant, that's 0.967. And remember that your reference angle comes off of your x-axis values. So I want to find this angle, whose reference angle value is 0.967 in quadrant 2. And notice that's just from pi going back 0.967 units. So if I do pi minus 0.967, I can easily plug that into my calculator. So I can do pi minus 0.967, and that will give me 2.175. And so that's my final answer there. And notice, if I took the sine of this expression in my calculator, I would also end up with 0.823, which is exactly what I'm looking for here. Because if I do 1 divided by that answer, 1 divided by 0.823, that would get me back to my cosecant of 1.215 right up here. So my final two answers here are my 0.967 and my 2.175. And I could plug those back into the original quadratic to confirm that.